Welcome to Cybersecurity Unplugged, the Cyber Theory podcast where we explore issues that matter in the world of cybersecurity.
Good day, everyone. I'm Steve King, the Managing Director at Cyber Theory, and today's episode is going to explore the world of software flaw detection and beyond. Joining me today is David Brumley, the CEO of For All Secure, a cybersecurity company whose products are based on Mayhem, the amazing machine that David designed to autonomously and in real time apply patching and continuous penetration testing. In fact, it won the DARPA Grand Challenge by demonstrating that it could fix its own software security flaws at DEF CON 24. David is a professor at Carnegie Mellon University as well. He's also a very well-known researcher in software security, network security, and even applied cryptography. Professor Brumley also worked for 5 years as a computer security officer for Stanford University. So welcome, David. I'm glad you could join me today.
Thanks for having me on your show.
Thanks for being here. Let's start with your amazing machine dubbed Mayhem. Can you tell our listeners the story, which is a great one, of how it was developed and the process of delivering that crazy level of performance?
Yeah, well, it actually started back when I was doing IT. I was, as you mentioned, the computer security officer for Stanford. Really, to date myself, it was when it was called google.stanford.edu as opposed to google.com. So that's how long ago it was. People just kept breaking into systems and they kept breaking into them by finding software flaws. And so that started me on a crusade of trying to figure out how we can teach machines to find and fix those flaws first. And so I went back, got a master's, got a PhD, actually got tenure at Carnegie Mellon University, all looking at how can we teach computers how to hack. And then in 2014, DARPA put out a challenge based upon my research and a couple others that says, hey, can you prove that these sort of results are really going to be meaningful to the world? And so we took that research and we entered the contest. And we were able to show that, yeah, we could teach computers to hack. In fact, they could find and fix software flaws in minutes.
You know, if that's true, it makes me wonder why the Biden administration hasn't insisted that everybody install one.
Well, that would be great business for us.
It certainly would. It certainly would. After Mayhem's debut, you won a 2-year contract with the Pentagon's startup-centric unit called the Defense Innovation Unit Experimental, DIUX, which is a mouthful, to find coding flaws in both operating systems and custom programs used by the U.S. military. Is this program still going on, and how did Mayhem perform there?
We've actually completed that. And so if you look at it, right, when you're in research and you're showing something as the art of the possible, you're really doing it in a controlled lab setting, which is a little bit artificial. And then the DARPA Cyber Grand Challenge, next level of maturity, but very much showing the art of the possible. What this program was about was taking that art of the possible and trying to, what they call, bridge the valley of the death, right? Where you have great ideas and they never reach into industry to help foster that. And so this was really a 2-year program to show whether or not those things that we demonstrated at DARPA on this artificial terrain could really be turned into something that worked in real life for real customers. And so that's when you start to think about, what does it take for the system to ride alongside a human? What does it take for this to be incorporated in business policy and procedure, and how developers and security professionals work? And so we took 2 years of that. And then at the end of that, they did an evaluation to determine, have you shown with real customers in the DoD, but this wasn't just a cool research project and still needs a little bit of time to bake, but something that they could use today. And I'm happy to say at the end of that, they awarded us a $45 million contract because indeed, I think we're being used in every DoD branch. We're being used in the IC and several other areas to help make software safer.
Oh, wow. That's beats a Series A round, I guess, doesn't it?
It does. Actually, what was interesting is from 2016 to 2018, when we were doing this, we were taking that research and we were maturing it for the DoD, but we actually did also get a Series A round. And the reason for that is we went and we were solving problems for the DoD. And at the time, and even today, a lot of what Mayhem is used for is to check weapon systems. And all a weapon system is a normal vehicle with some, added protection and some armament. What we wanted to do is start taking this also out into industry. And so we raised 15 million from NEA at the time. And so we've been supercharging how do we take this research and get it out into practice as quickly as possible.
How are you doing that?
I think we're doing well. I mean, it's really interesting as an academic who is really just most interested in how do we find and exploit software vulnerabilities to prove that they're true, but then also fix them at human computer speeds. What does it take to build a product? And for example, things that never come up in research, but come up when you're bringing a product or things like you have to do a little bit of education for your customers because people are used to doing things one way. And then you have to kind of pose to them, what if we were able to reduce human effort for you? It'll require you change the way maybe you do business a little bit, but it'll be in the long run. And so that's what we've been working on. We have some cool customers. We have a number I can't talk about. In fact, even in the DoD, a lot of the customers' use cases are classified because Mayhem actually finds real flaws. But there's a couple that we can talk about. For example, Cloudflare has signed an agreement that allows me to talk about them, where Cloudflare is using Mayhem to protect their constant distribution network.
Yeah, it's amazing to me that this doesn't happen faster when Mayhem is an obvious step up, which is an understatement in both time and accuracy in terms of trying to determine whether or not the software is solid or is got bugs. There are probably other side benefits to Mayhem's self-healing capabilities. Can you tell us a little bit more about how it works?
Yeah, I'll tell you a little bit about it, and I'll actually tell you the trade-off, right? Because there's no silver bullet in the world. This isn't just something that is exactly the way we used to do it, but a little bit better. That's not what the challenge was about. So back in the old days, and I'm talking about last year, people really what they thought they wanted was an application security product that would tell them where all the flaws are at. So kind of they were in this mental mindset of this thing is going to tell us where all the possible problems are at. We're going to put a human against that list, kind of check it off like your honey-do list. And then we're going to have safe software. And that vision has been wrong for a number of reasons for a number of years I could go on and on about it. But really what Mayhem did is it said, look, we're never going to say that we find all the problems, but what we're going to do is we're going to say every problem that we find, we can prove it. We have a witness, an actual working exploit that would trigger the vulnerability. And the longer you run Mayhem, the more and more of those vulnerabilities it's going to be able to find and prove. And so what it's actually doing is you can kind of think of a program like a recipe, right? A program is instructions on how to cook something. Mayhem is going through these incredibly long and detailed recipes and finding all the places that you end up with baking something that's bad and showing you, hey, if you do these steps, this is how you reach into this bad state. What we did in the Cyberground Challenge is then we would fix them. And what we found as part of our go-to-market, actually as a product company, is the automated fix is something that technologists are enthusiastic about, but there's a variety of actually legal barriers that prevent it from necessarily being the best approach today. For example, in Cyberground Challenge, when Mayhem found a flaw, it would automatically fix it. It would rewrite actually the program binary, the executable that was running on the system. But here you've ran into an interesting problem. Suppose Mayhem is being ran on a commercial product and we change the code of that commercial product. Well, you've licensed that product from a vendor and now it's been modified. And now that vendor may be upset. The vendor may no longer warrant it. And so like that automated fix, we haven't quite got there yet, mostly because of kind of this legal barrier of what do you do when you modify software that you yourselves didn't write?
Yeah, so it's not that you can't do it, it's that legal barriers exist that prevent you from doing it in terms of whether it's a good judgment call or not, right?
Absolutely. That's where we're at. And so as we build up the company and tried to bring this out to practice, we focused on how do we find and improve vulnerabilities? Because what we found is developers are just exhausted. Everyone talks about shift left and developers have to stop releasing buggy code and all these sort of things. Really, you've taken someone who loves to code and you've yoked him with this, security responsibility. What Mayhem has helped them do is really two things. Every time we say there's a bug, we prove it, or a vulnerability, we prove it. And the second is we actually help them better test their software just to make sure, good stuff works. Because at a high level, when you're doing application development, you want to test good things work, like, what I wrote it for really happens, as well as no bad things can occur. And Mayhem actually automates both for them.
Yeah, it's sort of like having 1,000 white hackers all organized around various different components of code, but not correcting it, just identifying it, it seems to me. And I know, if, those poor folks in DevOps and DevSecOps are, as you point out, indeed overwhelmed by all of this newly discovered sort of focus on what they do every day. And as a former programmer, it does hamper your style a bit. But you've got two products now. You've got this Mayhem for Code, which I think delivers the automated, integrated, accurate security testing, and then you've got this thing called Mayhem for API, which seems to provide similar automated tests needed to build quality APIs. Can you tell us about fuzzing, which is kind of at the core of that technology, and the impact it has on DevSecOps, as we were just discussing, and the role it plays in both your solutions and then potentially across the industry?
Yeah, absolutely. So if you go back and look through, how people have approached this problem of trying to find flaws in software, right? There's a couple different approaches. One is you can always look for the known knowns. This is saying you're using an out-of-date open source library and you should probably update because that open source library has a bug. And companies like Snyk and SourceClear and Black Duck do a great job of this sort of stuff. So that's not really what Mayhem is focused on. Of course, we can find vulnerabilities in that, but it's not that known. The other way of doing it, and which really has been the industry norm today, has been what we would call static analysis, where you take the program and you're essentially running a grammar check over it. And just like a grammar check, if you've ever had a Microsoft Word document and ran grammar check, you see a lot of suggestions that you don't want to take. And that's kind of the same experience programmers have. Mayhem, as you mentioned, uses something we call fuzzing. And fuzzing is actually just as old as static analysis. Static analysis really came out in the 1970s. Fuzzing actually predates that even a bit, where the original idea is if you give a program a bunch of random inputs, right? Like, so instead of a human interacting with a program, you have a bunch of monkeys just typing. Surprisingly, they found about 30% of apps you would trigger bugs, and actually pretty serious ones. Now, the research has moved way beyond monkeys. We actually, inside Mayhem, use hardcore latest research in modeling programs as mathematical equations, actually in applying something called SMT solver, some things that can solve mathematical equations to figure out where these equations can kind of capture where things are vulnerable, and then where they're true, that would give us a way to trigger them. So we're modeling the formal semantics of it. So that's what fuzzing is doing, is kind of conceptually, you can think of it as a million monkeys, except for it's not monkeys. It's actually, Deep Blue, it's the chess engines running on the program, systematically exploring them with the advanced computer science. And so when we first started doing this, and for the DARPA Cyber Grand Challenge, this is what we focused on. We focused on compiled applications. So we focused on, this would be your Go or your Rust or your C, C++. And the reason those are especially important, especially in the DoD context, is our critical infrastructure runs on those. Energy, airplanes, automotive, everything runs on compiled programs. But we also, of course, can't miss the fact that a lot of the world is moving towards web and SaaS services. Now, these aren't compiled programs. These are usually actually a system of systems. So when you talk about a web API, you're really talking about there's a little API piece of application logic and it connects to a database, and maybe that database has some other things feeding it as well. So really what we would call a system of systems. And so we built Mayhem for API to bring the same benefits that we had for Mayhem for Code, looking at a single application, to an API where you can just point it at an API. And even if there's 3 or 4 different computers that have to cooperate to bring that API to you, we can check it.
Is it being used today for NCI at all? I mean, we have no visibility. And I mean, it's one thing for Biden to issue an XORD and all the rest of that. Now, all of that was all good, but we have generally no visibility into what is going on around the critical infrastructure world in terms of protection, detection, what have you. Can you talk about whether Mayhem is being used for that today or no?
Mayhem within the Defense Department is being used to check weapon systems. So this would be things like airplanes and so on. We also have customers, and unfortunately, because of NDAs and respecting customers' privacy, we can't name their names, but we are being used in aerospace. We are being used in automotive. to go and check things. And what we're seeing actually are new requirements coming out for each of these industries. For example, automotive just had one come out called ISO 21434, which is about safety and security testing, where Mayhem really is one of the few solutions that just kind of plugs in and does it. So we're starting to see that. When you're talking about what's best for security, you can look at it from the technical perspective, and that's great. But as a startup, one of the things we're always looking at is the business perspective. And it takes time just for people to understand, oh, there's a new technology. We have to figure out how to adopt it. We have to figure out how to buy it. We have to make sure we have budget for it. All those sort of kind of things that go into actually using it. That being said, it's been, I think, incredibly strong uptick. So we've really only kind of had the product launch in 2020, and we have about 20 customers using it today.
I'm sure you pay attention to what's going on in the world of cybersecurity on an intimate basis. You've seen, of course, the attacks on Colonial and the water systems and JBS, et cetera. What do you expect is going to happen here, pushing out maybe 6 to 12 months into the future?
Well, if we look at it from a policies perspective, so Biden has surrounded himself with some really top-notch experts. That's the first thing that I want to comment on. People that I've actually known for a long time, like Chris Inglis, becoming the director of national cyber policy, are big deals.
Yeah, I agree.
Deep expertise, really deep technical expertise, and have been just public servants for a long time. Very smooth sailing. So I think that we're going to continue to see more and more policy. The first thing that we've seen is really the software bill of materials becoming an important part of it. And this is like the smallest unit that they could be doing. Really what they're trying to say is when you deliver a software, you should know what its ingredients are. And so that's going to happen. I think one of the things I'm interested to see is how much they lean into regulation. So historically, what's happened in the energy sector in particular, since we're talking about the Colonial Pipeline, is administrations have wanted them to self-regulate. So all the energy companies, for example, would decide what they thought was critical infrastructure and then agree amongst themselves they should protect it. But there's kind of a perverse incentive there because they would, for example, say, oh, that computer's not really critical. And they would say it not because it's not critical, because it's vulnerable. They didn't want to count it. And so I think there's a really interesting balance that has to be done here where in anything you do, you don't want to have huge amounts of government oversight just because of the speed of government is super slow and you're not going to keep pace with technology. But it's certainly not enough today. Like they haven't struck the right balance. And so I'm kind of interested to see how this goes.
Yeah, so am I. So you mentioned the fact that we've got some great people up there now. And like I said, I concur with your assessment, certainly. I'm just amazed that, but while you're right about the speed of government being, syrupy slow, I'm just amazed that if you've got a solution like Mayhem, why it doesn't get rolled out on a kind of a national level. I mean, we managed to get to the moon and in a few years, and we managed the Manhattan Project in whatever it was, 27 months on some very loosey-goosey nuclear science. I don't see why we can't have a similar program here to figure out how to ward off the onslaught from our adversaries. What are your thoughts about that?
Well, I've long advocated actually creating a Manhattan-style program within the DoD, especially around critical infrastructure. I couldn't tell you why it wouldn't happen. I know, for example, after Mayhem won the Cyber Grand Challenge the following year, two things happened. First, Congress actually put in language into the appropriations bills that said thou shalt start using Cyber Grand Challenge technology. Second thing that happened was an election. And as we know, Trump won the election. And so that language was basically ignored, right? Because Congress will say to do things, but they don't always necessarily get done as far as how appropriations works. And I think we need to revisit that about saying we need to invest in more cyber autonomy out there, because at the end of the day, like it's not just application security, even though, in my mind, most compromises, and DHS backs this up with statistics, are due to software flaws. Really, a lot of security is a cyber workforce problem where, theoretically, if for every developer we could pair them with an application security expert, it would be secure software, very, very good. But you don't have that amount of talent. For every computer network out there, we know IT people are just stretched thin keeping it up, let alone having enough security people. And so I think we really need to double down as far as a Manhattan Project and building out more autonomy.
Yeah, here.
And hopefully we'll see it.
Well, that would be terrific. And we're watching closely here. And I'm conscious of the time here, David. So I've got one final question. We talk about DevSecOps a lot here as we're rolling out our cybered.io online training and education platform at ISMG. We know that DevSecOps can be impacted positively by, as you say, either having a security expert sitting side by side or by automation, integration, and speed. While you acknowledge these issues, I know you do, you say they're symptomatic of a larger root issue, which is inaccuracy. What's your position on accuracy at For All Secure, and how can you guarantee that deliverable when so many others haven't been able to?
Well, the big differentiator for us is we're saying every time we say there's a bug or a vulnerability or something fails, we can prove it. And so that's what keeps your limited human resources really focused on what they can do best, which is creative problem solving, right? As opposed to trying to go through a big laundry list and figure out what's real and what's not real. And so, as I mentioned, the way we do this is every time we say there's a problem, we actually give you an input so developers can debug it the way they would any other problem. If you think about it, actually, DevSecOps is in a way what Cyber Grand Challenge was about, because it's about autonomous pipelines. If you get past the test phase, you can auto deploy. And so that's what Mayhem is about, is building that up with the idea that you don't want an extra human step in there always verifying everything and automate everything. And so I think that's really how Mayhem works. It's how it plugs in, and the way we guarantee it is every time we tell you there's a problem, we can actually just like if someone reported a bug, you'd ask like, how did you trigger it? Mayhem can actually answer that question. It's the first product that really does that.
Yeah, it's truly amazing. I wish you and For All Secure all the best here. You've got an amazing product. We don't normally, do these podcasts to promote companies, but I think your situation is remarkable and extraordinary. So I'm more than happy to help let the world know what you're doing and how cool it is. So thanks for explaining all of this. I'm sure our viewers want to hear more. So maybe we can get back together in a few months and talk about what's happened between now and then, and any progress that Mayhem's sort of achieved or traction during that period.
I look forward to it, Steve. And thanks for having me on the show.
Well, great. I want to thank you, David, for taking time out. I'm sure you have a crazy schedule, and I think we had a nice 30-minute chat about this, and want to thank our listeners for joining us in another episode of Cyber Theory's exploration into the complex world of cybersecurity and digital realities. Until next time, I'm your host, Steve King, signing out.
Thank you for joining us for another episode of Cybersecurity Unplugged. You can connect with us on LinkedIn or Facebook at Cyber Theory, or send us an email at social@cybertheory.io. For more information about the podcast, visit cybertheory.io/podcast. Until next week, thanks again.